Good afternoon, and thank you for being here, for staying until the end in this day of learning and sharing. My name is Danilo. I'm part of the Evangelist team, and I'll later be joined on stage by Caroline Rennie from Comic Relief, a company we all love. And the idea of this session is to dive deeper into how we can use serverless functions to build modern applications. So let's just start by defining what do we mean by serverless. Well, there is a nice way to look at that. It's how much time and effort you have to put into the operations behind maintaining some part of your application, of your architecture alive. Depending on the layers, it can be compute, it can be storage, it can be analytics. There are different services that we can offer as AWS, but for each service, there is a shared responsibility between you, the customer, and us, the provider. And depending on where this boundary lies, we can do more things or less. If you use an EC2 instance, we definitely take care of the physical security of the EC2 instance and anything happening up to the hypervisor. But we can't have access to what is happening inside the instance. With Lambda functions, you just have to provide the code, and we can really manage lots of things for you, including the scalability. This function can be executed once per month or 1,000 of times per second, and we manage the scalability for you. And I think that Lambda, that we launched at the end of 2014, so now it's going to soon to be 5 years, was the enabler of serverless architecture. Because with Lambda, you can build application in an easy way. You take your business logic, you group it in functions, and then you connect these functions to an event source that is triggering the execution of your business logic. This can be an API call, can be a change in state in a database, in a storage platform, like someone uploaded a picture or a document on Amazon S3. And this trigger fires your business logic that can be written in almost any language. We officially support Node.js, Python, Java, C#, F#, PowerShell, Go, and we recently launched also support for Ruby. But we also have the runtime API that we will see allows you to bring almost any language to the Lambda platform. And this function is your code, so they can do anything. They can reach anything available on internet or in your private virtual VPC or AWS, or even through Direct Connect on-premise resources that you have. This is the anatomy of a Lambda function. This is an example in Python, but it's the same in any programming language. Inside your code that can be composed of multiple files, multiple functions, there is a function that you call the handler for the Lambda platform. And the handler is a function that we invoke, passing an event and a context. The event gives you information on what is the trigger. Normally, it tells you this is the S3 file that has been uploaded, this is the payload, the HTTP payload of the API call that you received on the API gateway. The context is giving you information on the execution environment of the Lambda function. So, for example, it's telling you how much time you have left before your timeout runs out. And at the end, a Lambda function, you can call them synchronously or asynchronously. For synchronous invocation, you can return a result. Like if you're being called by the API gateway, this is a synchronous invocation. You must return an HTTP status code and optionally a payload. To make it easier for customers to build more complex applications, last year at re:Invent, we launched layers. Layers is as a way to package the dependencies of your application as a zip file. And in this way, the business logic of your Lambda function remains really small. Normally, we notice that most Lambda functions are in the range maybe of the megabytes, but most of the bytes is just dependencies, libraries, runtimes that you need to bring with you. The business logic is very small. So the idea with layers is to really leave only the business logic, something that you update quickly and easily in the Lambda function itself, and then bring the dependencies by connecting the Lambda function to a layer. And we also release some of these layers as AWS managed. Like, for example, for the Python environment, there is an AWS layer that can help you use NumPy and SciPy, two very interesting scientific libraries, very easily. You just connect and then start by using them in your Python code. And Lambda layers, as I said, are built by a simple technology. It's a zip file with all your dependencies that we will unzip under the /opt path of the Lambda execution environment. Layers are designed to be immutable, also for security reason, but you can create multiple versions and update the version at each Lambda function is used. You shouldn't care too much of dependencies, because if someone deletes a specific layer version, if a function is already connected to the layer version, it will still continue to work. We will manage that. You will not be able to use a deleted layer for new configuration, but old configuration can go on. You can also use publicly shared layers, but you have to be careful with security, because it's something that someone else was sharing online. So it's up to you to decide what you want to use or not. Layers are not to be meant as granular as a singular dependencies. A function can have up to 5 layers. So normally you can have a function with maybe all the standard dependencies and libraries that you use with your application. Another layer can be maybe the monitoring part, the monitoring tools that you use, but you shouldn't think to have any libraries in a different layer, because you can have a maximum of 5. And order is also important, because we will unzip in the specific order you provide. So if one layer is overriding a previous layer, it's just up to the content of the zip file. As I said, we also launched last year the runtime API. And I love this because this allows people that is using other programming language to start thinking about how to use serverless for their applications. So the runtime API is a new API that we created for the Lambda platform, and it's the same API that we are using to create new official language support. So the Ruby language that we added at the same time when we launched the runtime API is actually built with the same runtime API that you can use to build your own runtimes. And runtimes can be shared as layers. So here there's quite a huge community around to share different language support. So when we launched layers as AWS, we shared in open source a couple of layers for C++ and also one for Rust. Rust is a very interesting programming language, very safe, very memory safe. So if you are interested in learning new things, I suggest you to have a look at Rust. It's really interesting. So the runtime API works in a very simple way. So in the layer or in the function code, there is an executable file that is called Bootstrap. It can be a binary file, can even be a text script if you want. And this runtime is interfacing with the Lambda platform. It receives, using environment variable, the endpoint to connect to, and also it will receive the invocation, and it must return the result or the error of the Lambda function. So it's not that complex to build. And in our documentation, we have a simple implementation of a Bootstrap that allows you to run Bash code inside the Lambda. So you can build a Bash-powered API at internet scale if you want. Over time, we saw customers build more and more mission-critical application on top of Lambda, so we work closely with our compliance teams to give you the assurance you need to build mission-critical application on top of Lambda. And this is not just Lambda. All the tools that you would use normally for a serverless application, like S3, DynamoDB, Kinesis, Cognito, and so on. So they are all PCI compliant, so they can treat payment informations, and also HIPAA compliant for healthcare data that is, as you can imagine, very delicate to move around. If you have to start today with a serverless architecture, I would strongly suggest you to start with a framework that maybe is closer to the way you build and develop applications. So there's really amazing open source tools outside. So if you come from a scaffolding environment like Ruby on Rails or Express.js with Node, probably you feel in comfort if you look at the serverless framework. It's very well maintained and updated. If you come from a Python environment and you use tools like Django, Bottle, or Flask, have a look at Zappa. It's a tool that allows you to take your legacy Python web application and just put it into Lambda function, and then eventually you can optimize in a second stage. If you're into Go, also Sparta can be interesting. We now officially support Go on Lambda, but Sparta was providing the support when there was no official support from AWS, and it's still very interesting for the Go community on serverless. As AWS, we also try to simplify the way you can use and integrate serverless applications. And we have actually 2 different tools that we created. They're both open source. One is Amplify, that is more targeting front-end developers. So if you are into React, hybrid web framework, or even for a native mobile application with iOS or Android, then Amplify can help you configure automatically the backend and use and build a serverless application driven from the front end. For a more generic use case, we have the serverless application model. And so I would like to introduce you to Sam. And the serverless application model is an open source specification that is released with an Apache 2 license. So if everybody in the community needs to use something similar, they don't need to rebuild the wheel. And it allows you to create a template that is a simplification of CloudFormation. CloudFormation is our infrastructural code service, but it's very verbose, especially for serverless architectures that normally build lots of underlying technologies, because to build a Lambda function, you need a role, you need to link the Lambda function with a trigger, and so on. So if you use SAM, it's very easy. So for example, it's 20 lines of code. Here, you can declare that you're creating a resource that is a Lambda function. This Lambda function is using this specific role. This is actually a policy that I will dive deeper later on in the deck. This is the event triggering this Lambda function is an API, so this will automatically configure for you the API gateway. And this function is also requiring a DynamoDB table. And by the way, since an update of around 1 month ago, DynamoDB tables, if you don't specify the throughput, simple table are automatically created with as DynamoDB on demand. That is quite cool because you pay by the request and they can scale to the thousands of requests without you to having to do any configuration. To make it easier to use SAM, we also created an open source tool that is the SAM CLI that you can use to package and deploy SAM applications. So you can install it with pip, but you can use it with any language. You have then the SAM command, and you can use SAM init to initialize the configuration of your application for any specific runtime, like Python or JS, Go, and so on. And this will create all the directory with the starting code, the configuration. It will also create a unit test for the specific runtime using some many external libraries so that you know how to configure unit tests for your Lambda function. And if you enter inside the function, you can use SAM local, that is a subset of SAM, to do interesting things. So you can generate synthetic events. So for function testing the result, giving in input a specific synthetic event that you prepare is a very good way of testing if a function works or not. But I don't think you can remember by heart the old syntax of an S3 event or an API gateway event. So with generate event, you can generate an event from S3, API gateway, and then you can edit the text file and use it for test cases. You can also invoke the API locally, and we use Docker to emulate the Lambda execution environment, including timeouts locally. You can also start an emulation of the API gateway or an emulation of the API of the Lambda service for the invoke API. So if you use any the AWS SDK, for example, from a Java front-end JavaScript application, you can directly invoke Lambda using the SDK invoke API call, and you can redirect the SDK to localhost and use start Lambda to emulate Lambda locally. It's quite interesting. When you're ready, you can validate the template. This does some local check syntax so that you are confident that the syntax of the template is correct. And then you can use SAM build to do the local build of with installing, for example, with the compilation if it's Go or Java, or downloading and configuring the dependencies if it's Node or Python. And when you have the build, you can then package and deploy your application. And if you iterate in these 4 commands, you can really very easily implement a CI/CD pipeline. So you can just validate, build, package. This will upload your function to S3, and then deploy to CloudFormation that will compare the previous configuration, the new one, and change the application code or the configuration of your S3 buckets, functions, or whatever is inside the architecture of your architecture. These 4 commands can easily be integrated with Jenkins or whatever tool you use for deployment or automation. You can also see locally the logs of your Lambda function. So the logs of the function are automatically collected to CloudWatch logs. but sometimes developers, they want to have a local experience. So even if your function is executing remotely, you can use some logs to get your logs locally. And if you add the -t option at the end, this will tail the log remotely, so it will keep the command running, and you continuously get the logs from CloudWatch logs, so you can really do some tests and see how the function is behaving with a local feedback. So it's an interesting toolkit for development. And you can also publish and share your application using the serverless application repository. This is a way to share your application privately within your account or publicly with everybody in the serverless community so that people can find ways to start and build an application. So the serverless application repository has an external portal where you can search applications. You can want to build an API, you want to build a URL shortener or something like that. You can search for a reference implementation here. They are all open source and contributed by the community, and you can use that, download the same code and the function code and start customizing your application if you want, or you can just install it in your account and run it in your account. And with the serverless application repository, we also start exploring the idea of composing serverless application, making different applications work together, like having nested application. This is an interesting idea to have more complex application without having a complex code base to manage. So let me make you an example. Most customers, they want to monitor social media, and they want to monitor if there is a mention of their product or their brand. But then the action that they want to take, if they are mentioned, is different. Some customers, they want maybe to run sentiment analysis on the tweet, and then if they are negative, they pass the tweet to customer support. Other customers, they just want to store the tweets locally and then do some data processing. So here we have two things. There is a standard component, the fact that I want to search Twitter continuously for my brand or my product. And then there is a custom business logic, what I want to do with my tweets mentioning my product that is unique to me. So how can we simplify building an application like this? So building the application serverlessly is very easy. So you can use, for example, CloudWatch events to automatically trigger a function every few minutes. This function can use the Twitter search API. And the Twitter search API returns you a checkpoint that tells you the last time that you search, so that you can store the checkpoint on DynamoDB. And then the next time, you can start from that checkpoint and see if new tweets have been published after that checkpoint. And this is completely standard. Only the Twitter processor is something custom. So we publish actually this standard component as a serverless application, and you can now nest a serverless application inside another. So this is an example of how that would appear into a SAM template. You can say, inside my application, when there are maybe other functions, other S3 buckets, tables, I want to include this application as nested. This is the ID of the application. This is the exact version that I want to embed. And this application has some parameters. So in this case, I can say the Twitter processor function name is this my function. That is another function that you configure in the same template, for example. And then the text to search on Twitter is serverless with some filters. This is the syntax of the API. So in this way, your application is one function plus this code, and it will automatically embed the search into your application without having to copy and paste one line of code. The SAM templates are quite powerful because they inherit most of the capabilities from CloudFormation. So, for example, you can use any resource that is not directly supported by SAM. You can use just the CloudFormation version, so kinesis, step function, for example. You can use parameters, mappings to create templates that can be reused in different environments or under different conditions. Like this is the same template can be used in test, where maybe the configuration or maybe the password of the database is different than in production, or things like that. It also supports outputs and import value. That is a quite interesting feature because it allows you to connect different stacks together. One complaint that sometimes I get from customers is that CloudFormation templates can get too big, and the stack is including lots of things. So to avoid that, you can create a more smaller and modular stack and then connect them together. So let me give you an example. This is not a serverless example because this works with plain CloudFormation, but works with serverless as well. So if you have an application that has maybe some web server, this web server needs to use some network configuration. And instead of having a single template, you can have two templates that create two stacks. So one template is managed by the network team. One template is managed by the application team for the web servers. So this is also creating a better segregation of duties. And then in the network stack, I can say, I want to output the security group and the subnet that I created. And then you can export this and import this value in the other stack. So in the stack A, you can export that, and I use what we call a pseudo parameter. So AWS stack name is a parameter that is already provided by us and gives you the name of that stack. For example, network of my app. And then in the other app, you can pass as a parameter the name of the network stack where this parameter needs to be taken, and automatically is appending the second part of the naming so that you can import the security group ID, the subnet ID, and so on. In this way, you can create more granular and smaller and easier to manage CloudFormation templates and connect them together. So it's something that you should look at, and this works for serverless as well, because you can have one stack that is creating the DynamoDB tables where maybe a DBA team is working on, and then another stack where the application is configured, and another stack for the VPC that the Lambda functions are using. Lambda function can accept also parameters, and there are three ways to pass a parameter in a clean way to a Lambda function. One is environment variables, and this is something that I suggest you use for parameters specific to a single function. If you have parameters that must be shared across multiple functions, you can use the parameter store from AWS System Manager. And if you have a secret, even better, you can use the secrets manager that can automatically rotate passwords for you, either automatically if the password is from an AWS service like RDS, or you can create another Lambda function that is managing the credential rotation for you. And credential rotation is critical for compliance. So normally, if you start to reach a certain level of security for your application, you must have some way of automating credential rotation. Also, the API gateway has the possibility of having parameters. So in this case, the stage variables that are depending on the different stage of the API. So an API can have a production stage, a test stage, or you can have different stage for different version of your API. They are part of the URL of your API. And each stage can have their own environmental variable that can be passed to customize the behavior of the implementation, because these stage variables will go into the context of the Lambda function that is invoked by the API gateway. So let's see a little bit of more complex setup here. So here we have a configuration here, a CloudFormation template, a SAM template actually, with some parameters. And one parameter is my environment. And this parameter can only accept three values: test, staging, and prod. So I want to create a template that can work for these three kind of environment. And then I have a mapping. A mapping can map each of these environment with different feature. In this case, I'm using a feature flag. So maybe I'm building a new special feature for my product. And I want this special feature to be with status on only in test and staging, and to be off when it's deployed in production for now. So these values are automatically used in the second part of the template. So the Lambda function in the environmental variable will reference the value of my environment. So the Lambda function can look into the environment and see if this is a prod, test, or staging environment, and can take different action depending on that. And also the spec feature environment variable is using a function that CloudFormation and SAM has, that is findInMap, that is looking inside the special feature map for the value of status for my specific environment. So in this case, it will get on or off depending on the environment I am. And you don't need to specify that as two different parameters. The second parameter is compute based on the value of the environment. And also the API gateway is getting in the stage variables the value of the environment. So this will be passed automatically to the Lambda function. They will know if this is a variable that is for an environment for production or not. AWS SAM also integrates very well with safe deployments. So I went deeper into that in my previous session today on CI/CD, so I'm not going deep now. But the idea is that you can just add a few lines into your SAM template where you specify the deployment strategy. and you can say, I want this function, when it is updated, to be deployed with a canary release or a linear release that will slowly allow invocation to use the new version and slowly roll back the old version. And you can monitor deployments using alarms. And you can also choose different deployment strategies here. So canary or linear deployments, as I was mentioning, they can be fast or slow, depending on what you want. And you can also add optionally two functions that are the pre and post traffic function that can be executed before and after a new version of a function is created. And they can be used to monitor your deployment. So for example, you create a new version of a Lambda function. Before any user has access to this function, you can execute a function that runs mock tests on your Lambda function. If they work, the deployment starts for your customer. If there is an error in your final test, we roll back automatically, and you get the old version that remains in production. And you can execute another function with your code at the end of the deployment, maybe to annotate your Git repo that this specific deployment is actually in production. Some templates can be quite long, so a good way to make them easier to read and understand is to use global parameters. So for each resource, like a function, you could say, I want to set up the default values. So for example, I can say most of my functions are in Node.js. They use this memory size, this timeout. Maybe they use an alias that is defined as an environmental variable, that is, or as a parameter that is passed to the stack. And then you can just use this as default, and then optionally you can customize. For example, the getBirds function is overriding the timeout to be 15 instead of 30 seconds. So this is a good way to keep default values inside a template. Another interesting thing is the permission model of Lambda, and this is quite generic with functions. So we have two sets of permissions here. Who can call a Lambda function? Like my API gate, we can call the Lambda function. And what the Lambda function can do inside. So what the function can do, can read from this S3 bucket, can write into this DynamoDB table. So the fact that there are two decoupled set of permission can help you create quite sophisticated security architecture. So for example, this can also work across accounts. You can have, for example, one account that can invoke a Lambda function running in another account, and then that Lambda function has the permission of reading or writing from those some S3 bucket based on some validation that they do. It's quite interesting. Still, creating permission and IAM roles in this case is quite complex, so we've looked for ways to make it easier for developers to create permissions. So we added to some, slightly more than 1 year ago, policy templates. So instead of using the IAM traditional syntax, you can give policy templates that give access to specific service and resources. So in this case, if you want to create a Lambda function that can poll from an SQS queue, instead of looking at what permission you need to give, you can just give the SQS poller policy for a specific queue name, that is, this case is a parameter that I pass to the template, my queue. And this will automatically set up all the permission for you. Actually, this is just one example. There are more than 45 predefined policies that are part of the SAM standard. And this is a short link to reach them. So you can take a picture, but I will make the slides available on my Twitter account a few minutes after this session, and all the slides will be also shared with you with your feedback email. So if we look, for example, here, this is the specification of the serverless application model. I make it a little bit bigger, but the screen is quite big. Can you see at the bottom? Yeah, someone is sleeping, maybe. There is, for example, for the SQS poller policy, let's make it a little bit bigger. This is the actual definition of the statement that we pass as an IAM role. So we give access to all these different actions on the SQS API. And for example, if you search DynamoDB, you have two policies, one that gives read-write access and one that gives read-only access. So the read-write access, of course, gives access to lots of different actions on DynamoDB, get, delete, put, and so on. If we go here, we have the read policy, and that gives access to a smaller and more limited list of actions. So you can use this document in two ways. You either use policies, or if you don't want to use policies, you can use this document as a reference of how to give permission to resources on AWS. But now let's see something more interesting. So let's see a case study from a customer that implemented a quite sophisticated and interesting journey. So let's welcome on stage Caroline from Comic Relief.
Thank you very much. Hi, I'm Caroline Rennie. I'm the product lead at Comic Relief, and today I'm going to be talking to you about our journey into serverless. First up, a bit of context for those of you who don't know Comic Relief. We're a UK charity with the mission to have a just world free from poverty. Over the past 35 years, we've raised over £1.2 billion for the projects that we support. And each year, we host something of a national takeover, like Red Nose Day, which gets the entire nation involved to get involved, raise money, and raise awareness for the projects that we fund. The public's response to our campaigns is incredible, but it does come with quite a few technical challenges. The majority of our traffic is driven by broadcast moments on the BBC. This means that we can never really predict what the response rate will be, and in order to scale for that, we need to be prepared. Our maximum donations this year for Red Nose Day was 350 donations in a single second. That's across SMS, call centers, and online. In order to deal with that traffic, we have to do some pretty clever stuff. So if you were to ask me, why did Comic Relief choose serverless? There's quite natural responses around our unpredictable traffic and our need to be able to scale and come back down when we don't need to be at scale. But that's not actually how we got into serverless. To tell this story, I'm just going to take us back to 2016, where our stack is completely non-serverless. For our 2016 campaign, our products could quite neatly be summarized into three groups. There was one Drupal 7 monolith, which dealt with basically anything an end user could want to do with Comic Relief. This platform was our CMS for static content. It could handle transactions, so paying in your fundraising money. Users could add their data so that we could claim gift aid on their SMS donations. We also had user-generated content in the shape of a fundraiser gallery, so people could add their images, and then we could upload it onto our site. And it was also able to do contact us functionality. I think in the keynote earlier, we touched upon briefly what's wrong with massive monoliths, so there's natural reasons why we moved away from this. Our other two products at the time were giving pages, which is where users could set up an account, create a page, share it with their friends, and get sponsored. And also our main donation platform, which was the one which was able to take 350 donations per second. This was multi-cloud and was one of our biggest tech investments of all time. So moving on to our 2017 campaign, we identified that the monolith was bad. But we also knew that we needed to change the way that we were addressing how we dealt with customers' data. So we built a Drupal 8 platform, and this would specifically only deal with our CMS-able content. And in doing so, we had to move into more of a microservice model in which we brought out functions like the paying in fundraising for transactions and SMS gift aid claiming form into their own individual applications. These were actually just built in Symfony, so we're still not serverless. But in 2017, we had our first serverless product. The fundraiser gallery was brought about because I basically deprioritized it for an entire campaign. With about 2 weeks to go, my stakeholder was pretty miffed and had asked, where's my gallery? Luckily for me, I had an engineering lead who was really keen to test out serverless and a front-end engineer who'd been playing around with React on the weekends. Within 2 weeks, we were able to pull together a viable product, which was able to, users could upload images to it, add their email address, add consent for us to host their image on our website, and the fundraiser gallery was born. We dropped the entire application into an iframe on the Drupal 8 platform, and we had thousands of images uploaded within a couple of weeks. So with that sort of spring in our step, we moved into 2018, and we're finally getting rid of the really awful Drupal 7 monolith. In doing so, we had to take the Contact Us form into the serverless world too. It was a great opportunity for us to upskill more of our team. So we were doing, at this stage, React in the front end, using the serverless framework, and Node.js in the back end. We started using this for sort of our go-to for any discrete products. Not necessarily big things, so things like a Red Nose Day competition where schools could design the next red nose, or a calculator where teachers could upload their steps for their school for our Sport Relief Challenge. So they weren't necessarily really big, important products, but they were areas for us to learn and get which tools we wanted to use. It was also an opportunity for us to identify reusability. So things like our mailer service, which is any function where we need to send a transactional email. We were able to use the same service across multiple products, including those which weren't in the serverless stack yet. So the mailer service and postcode lookup were 2 examples, and hosting all of our React components in the storybook was another great win for reusability. So as I touched on, we're not yet really dealing with the big boy products. But in 2019, we were able to bring our donation platform and our SMS gift aid form into the serverless framework. We also identified even more reusability, so payment service layer, which we can plug in any of our applications to take donations or transactions. We've got our image uploader service, marketing preferences as a service. Basically, anything you do can be done as a service when you move to serverless. So I think the most important thing in terms of our journey of how we got to where we are now is that we didn't start with our highest value product. If we'd have gone to our stakeholders in 2016 and said, I reckon we could do donation in serverless, we would have probably been laughed out of the organization. We built confidence by starting with a product which nobody really gave a hoot about. So my one sort of takeaway would be for you is to identify what your fundraiser gallery is in your organization, go and move it into serverless and see what wins you can make. Also, you can fail in the private there rather than quite publicly. Cool, so I'm now just going to go into a bit more detail about our donation platform. If you want to get a better view of the architecture, there's a bit.ly link which you can go to. So just to start off with, to give an idea of just how quick serverless development is, we deployed our first code for this application in April 2018, and we were taking live donations in production in September 2018. We did this with a team of 2 to 3 engineers, and it was also over August, so most of them were on holiday half the time. One of the best things about our platform was that we were able to build parity with the previous platform, which had been multi-cloud. But I'm just going to go into a bit of detail of our old platform versus our new one. First up, a bit of context about the old platform. This was built and used for 6 years on our night of television. It never failed. It could take up to 350 donations per second. And one of the reasons why it was so brilliant was how resilient it was. Resilience was one of those factors which we were sort of concerned about in terms of could we meet that functional parity. And I just want to draw one sort of comparison in terms of how we dealt with it differently in a serverless world to a multi-cloud world. Within the old platform, we had multiple Redis data stores where we dealt with queuing, so if something was going wrong, we could switch which region we were in and which cloud we were directing users to. And that meant that we built in that resilience so that we could retry donations. Within serverless, that doesn't really make sense. So instead of building the same product across multiple clouds, what we've done is built in redundancy through using multiple services. So if RDS were to fail, we've got everything in SQS. If SQS is failing, we've got everything backed up in S3. So it's just about building in redundancy through multiple services rather than replicating your code in multiple clouds. One of the biggest wins that we've had, which got touched upon in the keynote earlier, was our cost savings. Our March 2015 costs were over $83,000 for hosting, compared to under $6,000 for this March. And that's a pretty big win. That's about 93% saving. Just a quick call out that all of our hosting costs are covered by corporate sponsors rather than by the public. But actually, if we look at the win of what the serverless application actually has done for us, lots of these costs are actually our old infrastructure costs. The cost of our on-the-night platform was $92 for hosting. And the best thing about it is that we could do it all tomorrow, and it wouldn't cost us more than $92. So I'm just going to go into 4 things which I hope will be useful takeaways for you if you're already working in serverless or if you are just starting out on your journey. The first thing is you need to identify your limiting factors. For us, we've got pretty niche requirements in terms of requiring really high donations per second or transactions per second. But when you move into a serverless framework, you're going to be pushing some of the problems which might have been dealt with in your own hosting downstream. So for us, the way that we mitigate this problem is that we integrate with multiple payment service providers, which means that we can balance transactions across WorldPay, Braintree, Stripe, and PayPal in order to make sure that if we're having a peak moment, their systems can keep up too. For you might have something similar in terms of a database, which could be a limiting factor. So if you put in circuit breakers, you're able to mitigate that risk. But it's just about identifying it and then mitigating against it. The second thing I'd advise would be to really utilize rapid reusability. I've already touched upon our mailer service and postcode lookup and payment service layer, which are all great and can be used across all our products. But something which is a bit of an unsung hero, I think, is also our Lambda wrapper. This meant that our engineers don't have to do boring, repetitive code around testing over and over again. They can just apply the Lambda wrapper and release. One caveat here is that it means that you really need to make sure that code works, otherwise you'll break everything. Third thing would be to monitor to optimize rather than just to identify problems. We use a combination of Sentry, Grafana, and IOpipe, which means that we can know what's going wrong, how many users it's affecting, and what we can do to fix it. And it's very much down to an individual function level. But it also means this kind of observability enables us to look at which payment service provider is converting at the highest rate and then push more traffic through that. So you can really do it in real time, and it's great to have that ability to see what you're doing. My final point would be to use serverless to load test. And this is something which I think hopefully lots of you could go home and do tomorrow. We do it across all of our products, not just serverless, but the difference has been incredible. Whereas previously we would take maybe 2 weeks to prepare for load tests, we'd have to pay for hosting, having scaled up our systems to deal with our load tests to 300 donations per second. Now we're able to do it basically as a democratized service using the serverless artillery. We can do drip, slam, and ramp tests, and this is just, this slide just demonstrates what that looks like. If you are able to do it, please give us a shout, and it'd be great to hear how that works for you. I'd just like to close on 3 things that we wouldn't have been able to do any of this without. The first one is inquisitive engineers. Our team, well, we're quite a small team, and before 2016, we didn't have any serverless experience. If our team hadn't been willing to learn new skills, new frameworks, then we wouldn't be where we are today. And if you're in a situation where you want to be adopting it, you need to give people space to learn and space to fail a little bit. So again, picking things that no one cares about to learn in is a really good idea. The second thing would be our great tech partners. AWS was a really natural choice for us when we went into serverless. We'd been using them previously for our hosting needs anyway, but they were just sort of leading the way at the time when we were wanting to adopt serverless. And we just have a great account manager as well, Jason, who pays me in beer to give him shout-outs. But he's been great in terms of opening the door for conversations about what's new in AWS, and we're always getting to get sort of early access to have a look at what's coming up next. Final thing would just be trust in our organization. I'm a big believer that trust should be earned, and again, going back to identifying your fundraiser gallery as the simplest, smallest thing that you can move into serverless, and then building trust and identifying when's the right time to take on your big products. So with that, I'd just like to say thank you very much. We are actually taking donations all year round now, so if you want to check us out at comicrelief.com/donate, please give us a try, and enjoy the rest of the conference. Thank you.
Thank you. Well, you have time to do some load testing on the platform if you want. This is the URL. And with that, thank you. I think that the whole team at Comic Relief really deserves a round of applause. And this is the final session for the day, but if you can, stay with us. There's a network reception, so we can chat and go on with this day. Thank you.